And we always start with the y-intercept, which is 20, which means we're going to go on the y-axis, not the x-axis. It's a y-intercept, not an x-intercept. We go up 20. 5, 10, 15, 20. There's 20. And we will put a dot there, just like that. That point must live on the line. Look at your graphs. That point's there, right? And on all your answers, you'll have that point, right? Now, to get to the next point, we are going to use the slope that Keegan mentioned here. And I told you earlier, just a second ago, that the slope is always your rise divided by your run. So I'm saying that your slope is always a fraction. It is always a rise divided by run. But when you look at the slope 5, it's not a fraction yet. Yes? Yeah, we're just going to write it 5 over 1. Now it's a fraction, right? And so this tells me that to get to a new point from this point, not from the origin, from this point to get to another point on the line, I need to rise up by 5. And this number down here, since it's a positive 1, means I go to the right 1. Okay? If this were a negative 5, I'd come down 5. If this was a negative 1, I'd go left 1. All right? So from this point, I need to go up 5. That would take me to 25 up here, right? Up 5 and to the right 1. And I'm just going to come down here and put 1 here so you can tell that it came to the right 1. And up to 25. And now I draw a line here like this. And I'm done. What does this one not give you that what you did here did give you?
What x is?
Yeah, this does not tell us what the x-intercept is, right? Did not tell us that. In your problems, you found the y-intercept, x-intercept, drew a line. Here, I drew y-intercept, slope, and then draw a line. But they are the same line. Okay, they are the same. So what do you think of that method? Huh? I mean, it's a little different, right? So the place that this has a huge advantage is something like this. Have you ever seen this equation before? Yeah, we just did that a second ago, didn't we? And if we kind of look at that and squint our eyes, this is kind of like y equals mx plus b, right? Y equals mx plus b. Here, the b would be what? 0. So if I were asking you to graph this, you would go and start by putting a dot where? The origin at 0, right? That's where you would start. And then to get to another point, you would use the slope of 16, go up 16 to the right 1. Go up 16 to the right 1, draw a dot. And remember, it couldn't have negative hours, so. See, that was pretty clean, right? Just by using this idea. This is your slope, this is your y-intercept. What am I doing here? 5 minutes. Okay. So here's what we're going to do. Let me look at the packet real quick. I might just assign something out of the packet. Abigail here, yes? Jareth is here, and Sarah. Sarah, no? Let me just make sure I didn't. Alexis? Alexis, no? Jose, Allison? Okay. I'm going to see if maybe something out of the packet would. There it is. Okay, yeah. These are, I think, fair problems. On the packet, page 65, do you have your packet right there? I just want to verify that I have the right numbers. Can you flip to page 65? Yeah, okay. Page 65 through 67. So out of the packet, page 65 through 67. Read the instructions, because it's not asking you to graph every one of these linear equations. There's about 1, 2, 3, 4 things to graph. And then there's a couple they just ask you for the x and y intercepts. They don't ask you to graph them. So total there's 10 questions. So it's not a ton of work, all right? And let's just say have that done, make sure you've done that, you're comfortable with it. And the next class we'll do a little bit more slow, this method, and then move on to the next idea. All right? Any questions? Okay, y'all have a good weekend. Enjoy the Super Bowl if you're going to watch it. Yes, and thank y'all for being here. I appreciate you coming.